AI, machine learning, data science, you hear these buzzwords thrown around all the time, right? But what do they actually mean for a mining operation? Okay, let's cut through the noise. We're going to build a really clear mental model for how these powerful tools can turn all that raw data you're collecting into real, tangible business value.
Just think about it for a second. Every single one of your haul trucks is streaming payload and fuel data second by second. Your shovels are logging dig rates. The processing plant, it's constantly tracking pressures, flows, and reagent doses. It's just an incredible, massive amount of information.
And that's the billion-dollar question, isn't it? I mean, having the data is one thing, but using it to make smarter, faster, and frankly, safer decisions, that is the real challenge. And that's exactly where understanding the key players, AI, ML, and data science becomes absolutely crucial.
So to get this right, we've got to get our definition straight first. These terms are often used interchangeably, but they actually represent very different, distinct layers of capability. Let's break them down.
First up is artificial intelligence, or AI. Think of this as the big, overarching umbrella. It's the broad goal of making machines do things that would normally require human intelligence. Things like planning, reasoning, or perceiving the world. In mining, the classic example is an entire autonomous haulage system intelligently picking the best routes all on its own.
Now, sitting right under that big AI umbrella is machine learning, or ML. This is the engine that makes a lot of modern AI possible. See, ML is all about teaching computers to learn patterns directly from data, instead of us having to explicitly program every single rule. So instead of telling it, if the vibration hits X, then sound an alarm, you feed it thousands of examples and it learns that complex relationship all by itself. Pretty cool, right? And what fuels that powerful engine? Well, that would be data science. You should really think of this as the essential foundation for everything else. Data science is the whole process, collecting data, cleaning it up, analyzing it, all to generate insights that a human can actually read and understand. It's the discipline that tells you where you should even point your machine learning efforts in the first place. And this pyramid, this just nails the hierarchy perfectly. Data science is the massive base. It's where you collect and truly understand your data. Machine learning sits there in the middle, using that nice, prepared data to build predictive models. And then AI is right at the top, applying those predictions to create intelligent systems that actually go and do things in the real world. So the most crucial point here is that all of this, the whole pyramid, is built on one thing: data. Just like ore is the raw material for your processing plant, data is the raw material for intelligence. But, and this is a big but, not all data is created equal. On a mine site, you've basically got two main types. You've got your structured data, which fits neatly into rows and columns. Think of sensor logs, fuel consumption tables, tonnage reports. Easy. But then you have all this unstructured data. Rich, messy stuff like drone photos, CCTV footage, or even handwritten operator notes. Each type requires totally different tools to unlock its value. So, how do we make all this data useful for machine learning? Well, one of the most powerful approaches is something called supervised learning, which really boils down to this simple concept, an A to B mapping. We give the algorithm an input, which we'll call A, and the correct output, which we'll call B. For example, in predictive maintenance, A would be all your sensor data, vibration, temperature, load, and B would be a super simple label: did the equipment fail or did it not?
And once you start looking for it, this A to B concept is everywhere in mining. For ore classification, A is an image of the rock and B is the grade. For safety, A is a video frame from a camera and B is a label like PPE missing. For the processing plant, A could be ore properties and B is the predicted recovery percentage. The machine simply learns the mapping from A to B.
But here is the single most important rule of all, and you've probably heard it before: garbage in, garbage out. If your data is bad, your AI will be useless and it could even be dangerous. Simple issues like wrong units, faulty sensors, or inconsistent definitions can completely sink a project before it even gets started. Getting data quality right is absolutely non-negotiable.
Okay, so with that foundation in place, let's look at what a real project actually looks like. We'll start with a machine learning project, where the ultimate goal is to create a live, automated system that runs on its own.
A machine learning project follows this classic iterative loop. It's a cycle. You collect your A to B data, you train a model to learn the pattern, you deploy that model into a live system, and then, and this is the critical part, you get feedback, and you iterate,
You make it better and better over time.
Let's make this super concrete with an example, predicting a conveyor failure. First, you collect all the sensor readings as your A and your historical failure logs as your B. You train a model on this data. Then, you deploy it so it's live on your maintenance dashboard, sending out alerts. And as new data comes in, maybe because the season changed or you're processing a different ore type, you use that new data to retrain and adapt the model. It's a living system.
Now, let's contrast that with a data science project. The goal here isn't to build some automated system. No, the goal is to generate insights that we, as humans, can then act on. The whole workflow is different.
You see, the data science loop is all about discovery. You collect data, you analyze it to find patterns to test out your ideas, you recommend specific actions based on those insights, and then you go back and remeasure to see if your actions actually had the impact you were hoping for.
A perfect example of this is optimizing the haul cycle. A data scientist would come in and collect all the timestamps for loading, traveling, dumping, the whole shebang. They'd analyze that data and might discover, hey, trucks are consistently queuing up at shovel 3. The output here isn't a live model. It's a recommendation. Let's reassign 2 trucks from shovel 3 over to shovel 1. Then you remeasure to see if your tons per hour actually went up. Insight leads to action.
So, we've defined the key terms, and we've walked through the 2 very distinct project types. Now, let's bring it all together and see the complete picture for how you actually build an intelligent mine.
And putting it all side by side like this makes the distinction crystal clear. A machine learning project's goal, a running system. Its output, automated predictions. A data science project's goal, insights for humans. Its output, recommendations. The processes are different, but remember, they both depend on good data to succeed. They just solve different kinds of problems.
And the amazing part is, these approaches can be applied literally everywhere on a mine. We're talking optimizing operations with smart dispatching, predictive maintenance, better ore body modeling in geology, process optimization, safety incident analytics, even tracking your ESG metrics like emissions. Every single function in a modern mining operation stands to benefit.
So we'll end on this thought. Your mine is already a data ecosystem. It is generating unbelievable amounts of information every single day. The real question now is, what's the next step you're going to take to transform it into an intelligent one?